Lesson 21, Writing and Evaluating Expressions of Multiplication and Addition, is a continuation of understanding what our expressions are, but then it takes us to the next point where we're actually going to use those expressions to solve word problems. So here's our first example. The Italian Villa restaurant has square tables that the servers can push together to accommodate the customers. Only one chair fits along the side of the square table. Make a model of each situation to determine how many seats will fit around various rectangular tables. So, if you're making a model, it'd be chair, 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 chair. So with one table, you could have 4 sides. But then I'm going to go over here, and it'd be chair, 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 chair. So that's 1, 2, 3, 4, 5, 6. And then this one, chair, chair, chair. And that's 1, 2, 3, 4, 5, 6, 7, 8. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I did that wrong. There we go. All right. So if you look here, we have 4, 6, 8, 10, 12. So these are going up by 2. But what I need to do is I need to look at what my relationship is between this number and that number. So we go from a 2 to a 3 to an 8, a 4 to a 10. So let's look and see what's happening here. So for each table, on the ends, there are going to be 3. So we could fit 3 on the ends, 2 in the middle. 3 on the ends, 2 for every middle table. And so what you're doing is every table plus 2, because each table can always have 2 on there. And then you have to add the 2 ends to it. And so what you're doing is you're taking our table times 2, and then you're adding 2 on because you're adding 2 for the 2 ends. And so times 2 plus 2, times 2 plus 2. So it's times 2 plus 2. So that would be 102. Times 2 plus 2 would be 402. And then that's 2t plus 2, because that's the number of tables times 2 plus 2. So are there any other ways to think about solutions to this problem? That would just be up to you. This is the easiest way to think through it. There could be more complicated equations that you could set up, or you could continue drawing. That would be up to you. It says, is it impractical to make a model for 50 tables? Yes, it is impractical to make a table that is that big. If we did have a rectangle that long, how many chairs would fit on the long sides of the table? And so remember, the long sides, they're saying like on that side, that's what this first part was for. Taking our number of tables times 2 tells you how many can fit along the sides. And so that would be 100 seats would fit along the long side. It'd be the long sides of the table. It would be 50 on each side, because you'd have 50 on this side, 50 on this side, and then 1 there and 1 there. And then how many chairs fit on the ends of the long table? Just 2, because no matter how long the table is, still only 2 chairs can fit on the ends. So how many chairs fit in all? 102. And we're going to skip that one. And it says, let t represent the number of tables that make the long table. So that'd be 2t plus 2. So 2 times the number of tables plus 2. So let's look at the next example. Look at example 1. Determine the cost of various numbers of pizza. So Pizza Queen has a special offer. It's $4 a pizza. They charge $2 to deliver, regardless of how many pizzas you order. So that means we're going to add 2 no matter how many pizzas we order. It's 4 each, which means that's $4 for a pizza, and we're adding $2 to it. So determine the cost. So if it's 1 pizza, we take it times 4. you get 4, we add 2, the total cost is $6. So this is our delivery cost. We take 2 pizzas times 4, you get $8. And then you have to add $2 to it, so this one is $10. 3 pizzas times 4 gives you 12, plus 2, that's $14. We have 4 pizzas times $4, that's $16, plus 2, that's $18. So you see we're going up by 4 every pizza that we add. And that would make sense because it's only $2 for everything. So whether you order 1 pizza and it costs you $2 or you order 10 pizzas, it's still going to be $2. So the only thing that's being added onto it is that pizza, which is the $4. So we take 10 pizzas times $4. You get that it costs $40 and then $2 for the delivery. That's $42. Then we have 50 pizzas times $4 equals 200. Plus $2 is $202. And so then our P, we're taking $4 times our pizza plus $2 for delivery, and that's how you find it. So what mathematical operations do you need to perform to find the total cost? You had to multiply by 4 to find the cost of the pizza, and then you had to add $2 to find the total cost with delivery. So if the Booster Club had $400 to spend on pizza, what is the greatest number of pizzas they could order? So in this situation, what we said was $4 times the pizza plus $2 is equal to my money, how much it would cost. I guess we could do a C for cost. So now I need to figure out if my cost was $400, so C equals $400, it's going to be $4 times my pizza plus $2 equals $400. And the way that you solve this is you first start here with your addition or subtraction, and you're going to do the opposite of the symbol. So that's going to be minus $2, and we have to do the same over here. Take $2 off. And then that tells you that 4 pizzas are equal to $398. Now this is multiplication. We have to do the opposite, so we're going to divide by 4. And so you take 398 divided by 4. That's going to be 9. That's 38. Divided by 4 is 9. And it'd be 99.5. Well, we can't buy a half a pizza. And so the greatest number they could order would be 99 pizzas. Now, if the pizza price was raised to $5 and the delivery price was raised to $3, create a table that shows the total cost plus delivery. Now, I'm going to have you do this with a partner on your own because it's going to be the exact same as the one before. And then I'm going to do one more example for you, and then I'm going to have you and a partner do 4 and 5. And 6. So, actually, you won't need to do 6. I'll mark it out so you can see that. All right, Sarah is saving money to take a trip to Oregon. She received $450 in graduation gifts. She saves $120 per week, so that is $120 times a week. She has $450. Write an expression that shows how much money Sarah has after working W weeks. Well, that's already up in our sentence. So 120 per week, we're multiplying times a week, and then she already has $450. So our expression would be $120 times weeks, because they want us to have that W in the expression, plus $450. So that's our expression. Now it says create a table that shows this relationship. So in 1 week, we plug 1 in for W. That's 120 times 1 plus 450. And so 120 times 1 plus 450 is equal to 450 plus 120, which is $570. I go for 2 weeks. That's 120 times 2 plus 450. That's 240 plus 450, and that's $690. And then we take 120 times 3 plus 450. That's $360 plus 450. And that is 11 carrier 1, 810. So let's look here. What do we have happening here? There's a difference of 120 for each one, because the $450 that she already had stays the same. So the only thing increasing every week is the $120 she's saving. And so at this point, you wouldn't have to keep using that expression, because you can just add 120 to each of these numbers. So that's 930. That's 1,050. That's 1,170, 1,290, and 1,410. Now, if you wanted to just keep doing this equation, you could, and you would still get these numbers. It's just if you can see the pattern happening, it can be a lot quicker that way. The last question, the trip will cost $1,200. How many weeks will Sarah have to work to earn enough for the trip? So then you just look at your numbers. She needs $1,200. I go here. This is the only place that she has $1,200. She'll have a little bit more, but she has to at least have $1,200. If we went to week 6, she wouldn't have the $1,200 yet. And so you would say she would have to work 7 weeks. And then she would have the $1,200. So I'd like you to work with a partner and do 4 and 5. Please make sure that you have the answers written out so that I can check them. Only one partner should come and show me the work.